I'm assuming that you guys know like the basic of DFA, NFA, like you're not here for that. So I'm gonna just start solving questions from our papers last year. If you guys have any specific questions, you can give me and I'll do my best to solve them. If you have any doubts in the question that I'm solving, you can stop me and I'll like explain it to you again, no problem. So this is obviously the notation for NFAs and DFAs. I'm assuming you already know this. It's Q, sigma, delta, Q naught, and F. And I'm assuming you know what all this is. I'm not going to sit and explain that part to you guys. So the question that we're going to solve is this one. Consider, can everybody see my question? It's the first question on this PDF. Hello, can anybody tell me that? Just confirm to me that you guys can hear and see the screen. Yeah, okay. I think I'll just draw the solution here. So the question is, consider the set of strings on 0, 1 in which every substring of 3 symbols has at most 2 zeros. And all strings of length less than, but I don't think it's actually as hard as people make it out to be. So first state, obviously it accepts null empty string because it says all strings of length less than 3 are accepted. So from this we can go 0 and 1. It accepts 1, 0. And it accepts just the 1. And then from here, it accepts 0, 0 as well because 2 zeros are okay. It accepts 0, 1. One, 0. 1, 1. So all strings of length 2 are accepted. Now, when it comes to length 3 is where your issue arises. So 0, 0, 0 is not accepted. So let's send it out to some dead state because it's not accepted. 0, 0, 1 is accepted, but it becomes 0, 1. So let's send it to this state. And then 0, 1, 0 is also accepted, but that becomes 1, 0. And then, okay, so 0, 0, 0, 0, 0, 1, 0, 1, 0, and then 0, 1, 1. So for 0, 1, 1, it's a transition from 0, 1 to 1, 1, which is also accepted. And then 1, 0, 0 is also accepted. 1, 0, 1 is also accepted. 1, 1, 0 is also accepted. And 1, 1, 1 is also accepted. So this is your final DFA for this question. Does everybody understand what I've said and how I've drawn this DFA? Yeah. Is this clear to you guys? Do you want to take a picture or something? Guys, I'm just drawing something here, but if you want me to explain it again or explain it differently, then you're going to have to let me know, yeah? Okay, I'm just going to assume that means you guys understood, and I'm going to move on to the next question. The second question is defines 2 languages. The first language starts with A or B and ends with at least one A. Second language starts with A or B and ends with at least one B. So intersection of these 2 is going to be an empty set because it can't end with at least one A as well as at least one B. So it can't end with both. It has to end with only a single symbol. So that means the minimal number of states is 1, and it's just this. Nothing is accepted. So that's not like a big question to worry about. Now this one, This one actually tripped up like a lot of us last year. I actually very vividly remember this question. If L1 is a language containing blue and red, and L2 is 0, 1, 0, write down three strings that are in this. So this is concatenation. You guys know what concatenation is, right? Concatenation is, so if I have a string A, B and a string 0, 1, the concatenation of this is just the string A, B, 0, 1. That's it. Now, if I have to concatenate L1 and L2, so if I have to concatenate two languages or two sets rather than just two strings, I have to concatenate each item in this set with each item in this set. So that's blue 0, 1, 0, red 0, 1, 0. But the question asks for three strings. The trick is there are only two strings in the concatenation. There's actually no third string. What people did is people put epsilon. Epsilon is actually not in this concatenation. So ma'am tried to trick us by asking this question. It's actually just the two, and then you have to mention that there are only two strings in the concatenation of L1 and L2. Can I have some kind of thumbs up or something so that I know you guys understood? Yeah, okay, fine. Now, if the final states and non-final states in this DFA are interchanged, then what language will be accepted by the new DFA? So what is accepted by this DFA? So any number of B's and then one, and then any number of A's, and then either like BA, BA star, or BB star. So if I say BB star, that means at least one B has to already be there. So it has to be more than one B. Because if it's only one B, it's not accepted. If it's more than one B, it's being accepted. So this is a regular expression form. You can write this in language. So when they ask for a language, you need to write it in this format. So L equal to set of strings like that. You can write like a word description of this. That's the, you can write the regular expression as well. I think like as long as you show you've understood, ma'am should be giving you marks for this. Okay. Construct a DFA that accepts all strings over 0, 1 that contain a 1 either at the third position from the end or at the second position from the end. Okay. So whenever you have a number in the question, so third or second position, that will give you a hint about the number of states you need in your DFA. So if it says accepting all the strings which have more than 3 ones, then you need to have at least like 5 states. So you get a clue from the number in the question itself. So here it says third position from the end or second position from the end. So it's a 1, right? So from here, any number is accepted. And then this is, assume that this is the second position from the end. So that means this is the last position, right? So that means this is the accept state. So 1 and then 0 or 1 is accepted. But then if there is something after this, then also it's accepted. So if I say the string 1, 0, 0, 0, is the string accepted? 1, it's not accepted because it needs to be the third or second position from n needs to be 1. So if I have 0, 1, 0, it goes here 0, 1, 0, and it gets accepted. But if I have something like this, 0, 1, 0, 1, that also gets accepted. But this is a DFA. So what we need to do is define every transition. So define a transition from every state for every letter in this alphabet. So 0 and 1. So we have not defined uh, a few of those transitions. Let's get back and look at those. We have from Q1, if there's a 0, what happens? You can say any number of zeros, it just loops over itself. 1. Now, if there's a 0, again, that can't loop over itself because the position is something we're concerned about. And here, yeah, this is the end. So there's no transition after this. So it's fine. Yeah. If there is a transition after this, then you have to like put it back here. So wait. If this is a... Dude, okay. Actually, let me do this one again. I'm really sorry, guys. Yeah. Okay. The idea is we should try to have the least possible number of states in the DFA, the minimal number of states in the DFA possible. Sometimes they'll specify that in the question itself. They'd say draw the DFA with the minimum possible number of states. So there is an option where we can finish this in 4 states rather than going for the 5 states. That's what I'm going to try to do now. This is the 1 that we are checking for. And then this position can be anything. So whether this is the second position from end or third position from end, we don't care what the number right after the 1 is. So that way, this can be any digit, this can be any digit. But what we care about is from here, if we get another 0 or another 1, then what do we do? Because you can have something like 1 0 0 1 0 1. So we have a 1 0 0. But what happens here? Because it can't be accepted directly, we need to check if this is fulfilling the condition, right? So for that, the 1 gets directed back here. And the 0 gets directed back here. So from here, again, if the second or third position is a 1, it checks if there is 1 or 2 more digits after this 1. And that gives you whether or not this string should be accepted. So if you have the string 1 0 0 0 1 0, right? So 1 0 0 goes to Q3, and then 0 1 0 goes to Q2, and it gets accepted because second position from n. Yeah. So that's the answer to this question. I'll give you like a second to take a picture of it or something if you want. Okay. Now, draw a DFA that accepts any string which ends with a 1 or ends with an even number of zeros following the last one. Okay. So, first of all, any number of zeros is fine before the 1, right? Now, this is the 1. If it ends with a 1, we're okay with ending it here and accepting this. If it doesn't end with a 1, then if it ends with a 0, then we have to check that the 0 is even number of zeros. So you need to know the general form of like checking whether an even, like a string of even length has to be accepted by the DFA or a string of odd length has to be accepted by the DFA. Like knowing the base of that DFA will be helpful in solving a lot of questions for you. Yeah, so if it's a 1 here, then obviously it'll be accepted because if it ends with a 1, we're okay with accepting it as it is. It ends with an even number of zeros following the last one, we're okay with this. So just test a couple strings. What if I do 0, 1, 0, 0, 0? So odd number of zeros following the 1. This shouldn't be accepted. 0, 1, 0, 0, 0. So it's not accepted. But if I have a even number of zeros, then it is accepted. Yeah. So you need to know, let me just give you the general, like accepting an even number of characters in the string DFA. So even number of characters, as in we don't care whether the characters are 0 or 1, right? And also note that empty string, null string is an even length string because 0 is an even number. So this is the DFA which accepts even length strings. And if you just swap the accept state, you get the DFA that accepts odd length strings. And also you need to know like multiple of 3. Again, so you won't be directly asked this alone. You might be asked something in which you need to know this and then build upon this and draw the rest of the DFA. So that one was even, odd, and then basically a DFA that accepts multiples of 3, like accepts string whose length is multiple of 3. So if the length is like 3 or 6 or 9, it accepts it, but other lengths it doesn't accept. So for this again we need, so length is 1, 2, 3. For 3, we don't have to add a separate state. We can put it back here because again, 0 is a multiple of 3. 0 is a multiple of everything. So this is your accept state. So if your length of the string is 3, 6, 9, whatever it is, this DFA will accept the string. So similarly, you can actually, reason out the DFA, whether she asks like the multiple of 5, 7, anything like that. Usually she doesn't ask such complicated ones. 3, 4, and like 5, she might ask. More than that, I don't think she usually asks. 6, she might ask actually. Like find a DFA that accepts strings whose length is a multiple of 6. She might ask actually. Yeah, this is quiz 2. Quiz 2 is not there for you. Okay, now guys, we're done with the quiz 1 paper. I'll give you a second to go through this and let me know if you have any questions in this or anything related to this. Any questions you have on your own, anything, you can unmute and ask me now, or you can share your screen or text in the chat. I'll give you like 30 seconds for that. Yeah. If not, I was gonna go ahead and solve the Midsem paper. But before that, I was going to tell you guys some common things to remember. Okay, do you guys know how to convert an NFA to a DFA? Because that will be asked. I think that's there in the Midsem paper as well, but I'll just do a couple examples of those with you. So let me start with like a simple one. Yeah. Okay, so the first thing you need to know is to draw the transition function table. I think this is the way you get to know why it's an NFA. Like, what is the discrepancy with it that we need to solve before we can directly convert it to a DFA? Because as you know, in a DFA, every transition is defined and there are no like null transitions. In NFAs, a single state, like a state to state, may have multiple transitions. There can be null transitions, and there can be, in some cases, no transition for a given letter. Yeah. So the first issue is Q0 has two separate transitions for A. The second thing is Q2 has no transition for A. So we need to like fix these two things before we can draw a DFA for this, right? So what we can do is um wait, okay, I can't always see this. Okay. Let me draw A, B, Q0. So Q0 is my start state, right? I can define Q0, Q1 as a single state, as a combined state for the two, right? And what about Q0, Q1? From Q0, Q1, when I do the transition A, so Q0 transition of A goes to Q0 and to Q1. Q1 transition A goes to Q0. So it's Q0, Q1. And Q0, Q1 transition for B goes to Q1 and to Q2. So again, we can define it as a combined state. And then we have Q1, Q2. From Q1, Q2, A just goes to Q0 because Q2 has no transition for A, like we discussed here. And then Q1, Q2 transition B goes to Q0, Q1 because, again, if you check the NFA, you should just be able to get these directly. But which is the accept state in this combined states? Any state that contains the accept state from the previous NFA. So Q2 is the accept state. So here, if you have Q1, Q2, and you have like Q0, Q2, then anything which contains the Q2 will be an accept state. Yeah, we can just put a Q1, Q2 because we don't want to have a separate state Q1 and Q2. In fact, we can even have Q0, Q1 as your start state. But that way, I think it's too simplified. Let me just. Yeah, okay. So Q0 A goes to Q0 Q1 and okay. B goes to Q1 Q2 and then from Q0 Q1 A transition is to itself and B transition is to Q1 Q2. By the way, Q1 Q2 is an accept state, sorry. And then Q1 Q2 A is back here and B is back here. So there we go. This is the DFA for the given NFA in the question. We have actually a more complicated example in our Compre paper. I'll show you that as well. Yep, this one. Convert the following NFA to equivalent DFA. Here, the null transitions are going to be adding a little more complexity to the issue, right? So we need to find the equivalent DFA for this NFA. Let me draw it here. Let me draw the NFA first because I've changed the question. Like I've changed the slide, right? You can't see the question. Let me draw it in case you want to solve it yourself. So S is the start state. Okay, this is the NFA. Does anybody have an idea how to go about converting this to a DFA? So again, draw the state transition function. Sorry, not draw, write the state transition function. S. So from S we have like a null transition. Sorry, we don't have a transition for A and we don't have a transition for B. And for epsilon, we have transition to A and E. So you know the difference between the phi and the epsilon, right? Because sometimes even I get confused with that. Epsilon indicates an empty string, right? And phi indicates no transition for that particular alphabet. So just make sure you don't get confused with those two. And then for A goes to B, there is no transition for B. And then for epsilon, it goes to D. And then B goes to C, no transition. D. Wait, no, sorry, no D. Do. Yeah. It's still epsilon. Yeah. And then I think I've written too big, like the letters are too big in this. I'm sorry, guys. Yeah. C, there's no transition for phi or A or B, but there is a transition for epsilon, which goes to A. Right? For simplicity, let me actually just draw this like here, like under the DFA. Okay, the rest of it, I mean. Okay. Next, we have D, E, F, G, H. So D, literally nothing, no transitions. E goes to F and no transition. It also goes to G for A, by the way. I missed that. And nothing for P and epsilon. F goes to G for epsilon, nothing for these two. G goes to H. And H is an exception, so it just goes to E for epsilon. And that's it. There we go. Now, this is a very big NFA. So it seems quite daunting. It seems like a very big NFA for us to like convert into a DFA. But actually, we can get rid of it quite easily. So the first thing you need to note is here. So with D is accepting only empty string because empty string from S to A and empty string from A to D. So D only accepts empty strings. So that way, one of the accept states is simplified for us. And the second thing is H. So for that, we can follow the conventional method of, writing the transition function. So if I have A and B, what I can do here is I can remove this S state entirely because all it does is accept empty string. And instead of S, we can have combined start state of AE. That way we can, we don't have to deal with the empty strings. So AE. So from AE, you want to see what is the transition for A. So from A, if you give the input A, it goes to B. And from E, it goes to F and to G. So you can write down a combined state called BFG. And then for B, if you check the same thing, it's actually nothing because neither A nor E has a transition for B. So let's just put X for now. Let's create a dead state and send it there because this is a DFA. We need a transition for everything. Now, rather than listing out states from this, let's just list out the states from here. So BFG is the new state that we have found out. From BFG, we want a transition for A and for B. So from B, the transition for A is C. From F, it goes to G actually, right? So it's an empty string. That means that A goes to G or B goes to G, both goes to G. So let's just say for B, F, G, it is C, H. Because from F, the empty string, and then it goes directly to H. So might as well just consider it as H. So C, H, C, H. And then for B, actually, F takes the input of B and doesn't parse it and goes to G. So that doesn't count as parsing it. I think we can just put it as going to the dead state again. And then finally, CH. CH is the except state that we have found. And CH actually sends the null transitions back to AE. We don't have the concept of null transition anymore, right? We can just send both to X. Like it accepts at CH, and then if anything more is taken as input, it just sends it to X. So now we have to actually draw this DFA. So if I draw it, I get this is my start state. Start state is an accept state because, like I said, D accepts empty string epsilon. That means that at start state, you can just accept an empty string like that. Then A goes to B, F, G, and then another A goes to CH. CH is an accept state because H is an accept state. And then B from this, and A and B from this all go to X, which is a dead state. So this is your final DFA. So that's converting NFA to DFA. The next thing I wanted to discuss is like, you guys are aware that there are questions like you need to do the union or intersection of two languages and draw DFA and NFA for those. So those might be asked. So the question is draw, okay, so L1 is the language of strings containing 0, 0. And L2 is language of strings ending with 0, 1. So if we want to find the DFA that accepts the intersection of these two languages, how do we do that? Well, in this case, we can actually do it pretty directly. So we can just draw a DFA which accepts strings which contain 0, 0 and then end in 0, 1. So 0, 0, 1 is accepted. And then if I have another 0, that's not accepted. So dead state. Wait, not a dead state. Okay. If it's another 0, then I need to send it here because I need to check if there are 2 zeros continuously. Otherwise, it's not accepted. And if it's a 1 from here directly, again, same thing. So I can just draw directly the combined DFA. But what if you're given the DFA without being given the language? If you're just given two DFAs and you have to combine them. I think this must be there in your PPT. Basically, you can do like the example that we just saw of conversion, you can add a common start state. This is for OR, I think, right? And then you can have the first DFA and second DFA. So they have accept states here and here, which means it will accept the language accepted by the first DFA as well as the second DFA. So this is an OR condition. So in OR condition, your answer is pretty easy. In AND condition, you need to do a little bit more thinking and deal with it. Yeah. So I think now we can take a look at the Midsem paper. This is Compre. Yeah, this is Compre paper. Yep, there we go. Okay, so this question is a theoretical question, but I think we can still discuss it. So L is the language where the string contains more occurrences of AB than BA. Can a DFA be used to recognize this language? No. And the answer for this is actually given here. See, it requires counting and is not regular. So if it requires counting, then you can use, I think, Turing machine or the more advanced ones which you learn post Midsem. You can use those for these languages, but not DFA. Does the alphabet of language L contain more than two symbols? No, the alphabet of language L is just A and B. So no. Is it limited to true symbols? Yeah, she's asking the same question over and over to like psych us out. Actually, she did this last time. Is it possible to design a context-free grammar? Again, no. So context-free grammar, you can do it for a regular language, right? Um, L can be accepted by DFA. Again, she's asking the same thing. Yes, no, no. So regular expression requires a regular language. Again, so these are all theoretical things that you should just like be aware of based on the PPTs and stuff. She'll definitely ask like a good number of theoretical questions. Every DFA has an equivalent NFA. Obviously, no. I mean, every DFA is an NFA, right? So yeah, in that way, yes, sure. And NFA is more powerful than DFA. Yes, because an NFA can cover a larger variety of expressions and things like that. So DFA is not more powerful, and they don't accept different types of languages. Write a regular expression for a simplified version of the language where string contains at least one occurrence of the substring AB. So you can do A or B star AB plus A or B star. So the difference between the star and the plus is if I say A star, it means zero or more occurrences of A. If I put A plus, it means one or more occurrences of A. So minimum one occurrence of AB is guaranteed, but more than that, it can be any number of occurrences. So that's the regular expression that they're asking for, right? Okay. For the given CFG, make NFA and convert it into deterministic form. Okay. 0S1A. Yeah. Okay. So S is the start state. So 0S means it can take any number of zeros. So it can be 0S, 00S, 000S, and so on. So 0, I'll just do it as a self transition. 1 goes to A. And then from 1, you can put it as an accept state because just the string 1 is accepted. Just the string what, so 00 or like 0 being replaced for the A is accepted, or 000A is accepted, and if there is a 1, it goes back to S. Now conversion of deterministic form, actually the one that I've written here is actually deterministic, if you notice, so I don't have to convert it. It seems appears deterministic to me unless I've made a mistake or something. Okay, give regular expression for the following languages. Starts with 0 and has odd length, or starts with a 1 and has even length. So starts with a 0 and has odd length. Okay, for even length, what you do is, so you don't care whether it's 0 or a 1, the length is what you care about. So that way you can put this. So this is two symbols and then the whole star, which means the repetition means that it can be either 2, 4, 6, 8, like multiple of 2. So even length. For odd length, you can't just put 0 or 1 star. because that way it can be any number of, it can be 0 or it can be 1, 2, 3. So even numbers are included in that. So you have to specify it more specifically than that in the regular expression. So how we do it is we have 0 or 1. One second, let me make some space over here. Yeah, so 0 is the starting symbol, and then a 0 or 1, 0 or 1, 0 or 1. And then you star this, because this will be even. So even number plus 1 is an odd number, right? So any odd number can be generated from this. So this is the regular expression for A. B is it does not contain the substring 1, 1, 0. This one is a little tricky, because if you have a 1 and it's followed by a 1, so if you have 1 star basically, so 1 repeated indefinitely, it shouldn't be followed by a 0. So basically you can have 0 followed by a 1, but not 1 followed by a 0. So you can do it like this. So this is a valid solution. Then C contains an even number of zeros or exactly 2 ones. Okay, so even number of zeros, we can use the same technique that I just told you about. So 1 star, 0, 0 star, 1 star. So this is even number of zeros. Plus exactly 2 ones. So 0 star, 1, 0 star, 1, 0 star. So this means it can be no zeros. So it can just be 1, 1 is also an acceptable string for this. Or 0, 1, 1, 0, 0, 1, 0, 1. All these are accepted strings in this regular expression. So that's how you should, design the regular expression. Now, this question. Basically, you have to design a DFA that recognizes comment lines that begin with this, end with this, have only A's and B's in the middle, but no hash and backslash in the middle. So let's do that now. Are you guys following? Any difficulty, anything that you want to ask me? Okay, I'm assuming that's a no. So the first symbol and second symbol, sorry, that's too thick. I think I need to zoom in. Yeah. So the first 2 symbols are given. The first 2 symbols are the slash and the hash. So let me full screen this. Yeah. So slash hash. Now after this, whether there's an A or a B, we are okay with it. But the question says no intervening hash and then followed by a slash. So can there be a slash somewhere in the middle? So it can be AB slash AB B slash B A slash something like that. Is that acceptable? Presumably yes. And even a hash as long as it's not followed by a slash. So basically this is okay. But if there is a hash, we can take it here. And then if there is a slash, we can finish the comment and accept the string. If it's not a hash, if it's any number of hashes, we can accept it here. If it's like still an A or a B or like another hash, no, slash will be accepted. So if it's an A or a B, we need to check for another hash before we check for a slash. So we send it back here. So this is the DFA for this question. Yeah. Give CFG for the following language. L is equal to a power n, b power n, a power 2n, where n and m are greater than or equal to 0. So note that a power n, a power 2n. So this has to be twice the number of a's as this. That's what we need to remember in this question. So we can start with s equals, so you have a, b, and then twice the number of a's. So let's say capital A, capital B, twice the number of capital A, epsilon, because empty string is accepted, because n and m are greater than or equal to 0. So if both n and m are 0, then empty string is your result. So empty string is also part of this language. Then we have to define A. A is just the small a and B is just the small b, or epsilon. So basically, if I have a string like A, B, A, then it should be accepted. Like it can be generated using the CFG, but if I have a string like A, triple A, then it's not accepted, basically. That's the rule that we should be following. So any number of B's is fine. So it can be B. Oh, okay. Wait, guys. Okay, so it's not just the A. So it can be A or AA or epsilon, same BB, because it's not just the singular A or the singular B. It can be any number of these. But as long as this is 1 and this is twice the number of A's. So if I have A, double B, triple A, we can't generate it from here. Yeah. Okay, so next question. Derive the string. I think this question is pretty easy. So deriving the string and drawing the parse tree is not like a very difficult question. I'm going to leave you guys to do that for yourself. And then draw the NFA for regular expression. Okay. 0, 1, 0 star plus 0, 1 star plus 0. Okay, NFA. Now the string 0 is accepted, right? So this is an accept state. 0, 1 is accepted, but also any number of zeros is accepted. Like any number of 0 ones is accepted. 0, 1, 0 is also accepted. So if it's 0, 1, 0, it's accepted. If it's 0, 1, 0, 1, also it's accepted. So if 0, 1, 0, 1, you send it back to this state. And if it's like 0, 1, 0, 1, 1, then you can send it to a dead state. Or if it's like 0, 1, 0, 0, 0, then again. Yeah. So I think this is the DFA for this, NFA for this question. And yeah, it is an NFA because I haven't defined every single state transition for 0 and 1 at every stage. Yeah. Okay. Give CFG for the regular expression. Okay. Now I'm solving question number 8. We can have S equals A because it ends with an A. Okay? Or just the A, because here it can be nothing and just the A. A is also accepted. Now, what is the expansion of this A? So we have an A here, a B here, and then something in the middle. So A, B, B. Or A, so we can repeat this A's and B's any number of times. So it's basically A, B, B, C, B. This whole string repeated any number of times. Sorry, it's yeah, A B B B or A C C B. So one of these two strings repeated n number of times. So we can say A B B. B is of course B B or C C. But this whole string needs to be repeated n number of times. So I think we can just define. So there's an A here, and there's not really just a singular P here. So I think we can just say something like this. Yeah, that should work. And of course, epsilon as well. Yeah. But no epsilon here because we need at least one BBCC to be accepted. Okay. Context free grammar to generate L, where the first, middle, last character are identical. So either it's A and then something else and then A, something else and A, or B, something else, B, something else, B, or nothing at all. And then A can be anything, A or a B. So simple as that. Now we have a conversion of NFA to DFA. Have I solved this already? I don't think I have. Yeah, I don't think I have. Okay, let me do this then. So the given NFA is this. Yeah. So again, state transition table. So Q00 goes to Q0 and Q1. 1 goes to Q1. From Q1, we have both going to Q2. And then from Q2, we have 1 going to Q2 and no transition for 0. Right? So now we need to convert this to DFA. It's not that hard, guys. Yeah. So if I'm drawing, again, if I'm considering Q0, Q1 as a combined state, then from Q0, Q1, 0 goes, both go to Q2. And then from Q2, I can send this to a dead state. Just create a new tab state and just send it there. So there we go. Now I just need to draw this. And my converted DFA is yep. So since Q1 is an accept state in the given NFA, so the state containing Q1 will be the accept state in our converted DFA. So there we go. Now here, find the regular expression for the given automata. Okay. So this accepts a string, which is like any number of zeros and then a 1 is accepted, or any number of zeros, 1, any number of zeros. I think it's like, okay. any number of zeros and then a 1 and then any number of zeros, the whole repeated multiple times. Because if there's a second one, that becomes 0 1 0 1 repeated many times, and that it doesn't accept. So it accepts 0 1 0 or 0 1 0 1 0 1 0, something like this. 0 1 0 1 0 1 0. Yeah, this it accepts because it's 0 1 0, a 1, and then 0 1 0. Right? So I think that should be the regular expression for this question. And then give a simple description of the strings belonging to the language. So either repetition of zeros or it contains alternating, so it's repeating, so it's not like containing just 3 ones. It's like 0 0 0 1 0 0 0 0 0 1 something something 1 something something, right? And the whole repeated any number of times. So you can say either it's a 0 or it's a string that is zeros followed by a single one and so forth. Yeah, it's actually only 6:15. So if you want, we can cover the compre paper as well, like the questions which are relevant to you guys. We can cover that as well. Should we do that? Okay, I'm gonna take that as a yes because we have 45 minutes and you guys don't really have like doubts that you're asking. So I think this is what we should do. Regular or not, L1 equals alpha, beta, alpha, wherein alpha is belonging to set of 0, 1 star and 0, 1 plus. And here its alpha is only 0, beta is 0, 1. Yeah, this is a regular language, I would say. It's just that this has to be more than once because otherwise it would be a star. And this is also a regular language, I would say. Context-free language. So context-free language basically means that you should be able to define a context-free grammar for that. What is the condition here? Alpha, beta, gamma are all in this alphabet. Alpha is not equal to epsilon. So that means that there is a non-zero number of alphas. Absolute value of beta, or okay, not absolute value. Here this means the length. So the number of beta occurrences and number of gamma occurrences is the equal. So like I said, when it comes to counting and identifying the number of occurrences or saying like, okay, this has to have more occurrences than that, those cannot be covered under context free. So this is not a context free language. Those come under Turing decidable and recursive, that kind of grammars. Equal or not. Number of zeros in alpha is equal to the number of ones in beta and the number of zeros in gamma. Intersection of 0 star, 1 star, 0 star. So, okay. Basically, the 0 star, 1 star, 0 star means any number of zeros and ones. There's no relation between the number of zeros and ones. But here you want to define it such that the number of zeros and ones is equal. So it will be 0 0 1 1 0 0. So like that. So for that, this is the right way to define it. So if you have 0 1 0 defined in this way, then it does matter that, it takes care that the n value is the same. So the number of occurrences is the same. So they are equal. These two you don't have for Midsem. If a finite number of strings is added to a regular language A, then the resulting language is regular. I don't think that it is because when you define a regular language, it's not by the number of strings. So if I say every string that ends with 00, there is not a finite number of strings that do that, right? It's an infinite number of strings that end there because we are not defining the length. It can be any number of strings. So if I'm adding a specific number of strings, then it's no longer a regular language. Okay. The language 0 power n, 1 power n has regular expression epsilon or 0, 1. Well, no, because the regular expression for this would be yeah, actually this is the regular expression, because if I do 0 star 1 star, then I can't determine if that the number of zeros and ones is equal. But if I do it like this, then yeah, I can identify that the number of zeros and ones is equal. This is the drawback of a regular expression in regular languages, which you'll learn further. So if I have 0 star 1 star, that doesn't determine whether the right number of zeros and ones is present. If a language A has regular expression, then it must also have a DFA. It has an NFA, but not every NFA has it is a DFA, like we have identified. And these two are again not there for your Midsem. This question we have just solved. Give a context-free grammar. I'm not doing push-down automata. Give context-free grammar for this. So B power 3n, A power 2n. So basically thrice the number of B's and twice the number of A's. So give me a second. Yeah, okay. So strings such as B, 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 A, A, or 6 B's and 4 A's, these will be accepted by this language. So we need to define a context-free grammar for this. S B B B S A A, and of course epsilon. There we go. Simple as that. You just need one rule. No need to have multiple production rules. Give an example of two context-free language. I'm not doing this question, you guys. I'm sorry. Give for the given language L equals 0 power 2i, 1 power 3j, 0 power k, design an NFA. So, can we design an NFA for such a language? Yeah, because these are not related to each other. So, it's not like the number of zeros here has to be twice the number of zeros here. These are different letters. So, it has to be like even number of zeros and then multiple of 3 number of ones and then any number of zeros after that. So let me draw this here. Okay. So the given language is 0 power 2i, 1 power 3j, 0 power k, where I, j, k are greater than or equal to 0, right? Yep. Okay. Now NFA and then convert it to DFA. So let's start with start state. So the first thing we need to do is DFA to accept a string with even number of zeros. So again, empty string is accepted, and then any number of even number of zeros is accepted, right? Now here, after it has an even number of zeros, then we need to check for number of ones has to be a multiple of 3. So even if it has no ones, that's accepted. So here, even if it's just this string, this is accepted as well, right? But after this, if there is a 1, how do we check if it's a multiple of 3? So the first one, the second one, and then the third one. Now, what if there's another one? What if there's a fourth one? Then you just send it back here and check if it's a multiple of, I'm sorry. you just have the same except state, so don't complicate it like this. Yeah, so that you don't have to draw a separate except state. So here, third one. So if it has 4 ones, then it goes to this. If 5 ones, it goes to this. 6 ones, it goes back here, and it gets accepted. Wait, now the issue with this is if it starts with the 3 ones, it'll accept it. And then we're okay with any number of zeros as well. Okay, so if we have a string which is like 0, 0, 0, 1, 0, this shouldn't be accepted. And also 0, 0, 0, 1, 1, 1, 0, this shouldn't be accepted. So 0, 0, 0, and then 1, 1, 1. So we need to send this somewhere else. If there's a 1 after this, we can send it to a trap state, because if you have an odd number of zeros and then a 1, we don't want it. If there is a 1, it has to be after an even number of zeros. If there is an odd number of zeros at the end of the string, we are okay with that, right? And then we don't care about the rest of the string after. It's already not fulfilling our condition. And then multiple of 3, and then yeah, okay, so this is the NFA for this question. Now again, to convert this into a DFA, you need to draw the table. So 0 goes to Q1, 1 goes to Q2, and then from Q1 it goes to Q4. Okay. So here, if there is like a 0 at any point here, what would we do with that? We can just send it to a trap state, because again, it's not fulfilling our condition of a multiple of 3 number of ones followed by a 0. So if the number of ones is not a multiple of 3, then it fails our condition then and there. So I can just redraw this without having to go through this whole process, actually, because this one happens to be a simple one. Yeah. Okay, so if I draw here, empty string accepted, 0 goes here, and 1 goes here. And then from here, 0 goes here, 1 goes here, 1 goes here, 1 goes here. Now this 0 and this 0 can go straight here. And then anything from here can go back to itself, because this is a trap state. So I've just directly converted it to a DFA without having to draw your entire table of transition function. Sometimes it is this easy. Sometimes you do have to draw the entire transition table. Yeah. Okay, so write regular expressions for the following languages. Let me change colors just to mix things up. Yep. Beginning with 0 and having an odd numbered length. So beginning with 0 means it already has one like symbol, like one digit. So after this, if it has an even length, then you can say that it'll definitely have an odd numbered length. So after this, if I add the condition for even length, okay, I'm running out of space here. Let me write it closer. Okay, what if I write it here? Yep, okay. And then, not or, 0 or 1, 0 or 1, repeated as many times as necessary. Now, this is all strings containing less than 3 ones. So it will be a regular expression. So if I draw a DFU for this, it will be like this will be accepted, and then this will be accepted, and then this will be accepted, and then this won't. So less than 3 ones. So wait, 0 star 1 0. Okay, so we can just say epsilon or 0 star or 0 star 1 0 star, which is containing 1 1, which is containing 2 ones, and 3 ones onwards is not accepted. So this is your regular expression. And now the set of strings where zeros and ones appear in alternating groups of odd numbered lengths. So 0 0 0 star, 1 1 1 star, the whole star. I don't have to like repeat it over and over. Yeah. Okay. Honestly, we can do like, no, yeah, this works as well. Now you just need to draw DFAs for these. Okay, look at this. State transition diagrams with unnecessarily complex DFAs may not receive full marks. So you need to think about the simplest possible solution for a particular question. So let me draw the DFA for this one actually. So the other two I think are easy. This third one, let me draw it for you. Just to show you how it would go. So strings of alternating groups of odd numbers of zeros and ones. So first accept state, start state is an accept state because empty string is accepted. Then 0, just the 1 0 is accepted. And now from here I can set up the checking system for odd and even. So this is an even number of zeros. This would be still odd again, right? And then for 1, Q3, and then same setup where it checks whether there's an odd number of ones. And then if there is a 0 from here, so if it's just, so from this is an accept state, right? So if after an accept state we have a 0, 1 0, then it's fine. Same way if you have 1 1, then it's fine. If it's an even number, then it goes here and it checks itself. But what if there is a 0 after this? Sorry. Yeah. What if there's a 0 here? Then it just does a self transition. And if there's a 1 here, it just does a self transition. Like we don't care. Now that it has gone outside of our definition of language, we don't care what happens after this. So this is the DFA for this question. What is the next? Turing machine you don't have. I'm not doing this question. Okay, this is PDA anyway. Yep. Okay, so that is what I had prepared. Do you guys have any other questions, any other general doubts or specific questions that you wanted help solving? Did you gain anything out of this class? I hope that this was helpful for you. If nobody has any questions or doubts to ask, then I think that marks the end of the session. Thank you so much for joining, guys.